Welcome back. In part 5 of this module, we are looking at cloud architecture. But let's clarify what the cloud actually means. It isn't an abstract void. It is physical hardware, servers, cooling systems, and massive cables sitting in specific buildings, drawing power from local grids. When you decide to scale an application globally, you decide exactly where those physical machines go, and you have to make that choice without violating national laws, blowing past your operating budget, or needlessly increasing your carbon footprint. This chart outlines 5 constraints IT architects balance. First, latency is dictated by light speed. Second, data residency requires records to remain inside national borders. Third, redundancy ensures business continuity. Fourth, cost structure varies by location. Finally, carbon intensity measures the grid's renewables. Designing a sustainable multi-region architecture means solving a multivariable optimization problem. You are rarely maximizing just one variable. You are finding a combination that satisfies all these competing demands at once. You don't evaluate these 5 factors equally. You apply them in a strict, unyielding sequence, treating each one as a filter. At the very top of the funnel is regulation. Data residency laws are absolute. If a jurisdiction legally restricts where your user data can be stored, any region outside those borders is immediately eliminated from consideration. Once you have your legally compliant regions, you filter them based on your latency requirements to keep response times fast, and your redundancy needs to hit your uptime targets. Next, you apply your budget constraints to remove regions with pricing premiums you cannot afford. Finally, from the short list of regions that survive all 4 prior filters, you look at grid cleanliness. The region with the lowest carbon intensity wins. Choosing a region purely for its hydroelectric power does you no good if it places your application in a jurisdiction that violates compliance laws. Carbon intensity is the final refinement, not the primary driver. Once you have selected your regions, you have to decide how they actually share the computational workload. This introduces our 2 primary deployment patterns. This diagram shows active-active on the left. Both region A and B process live user requests simultaneously. On the right is active-passive. The primary handles all work, while the secondary sits idle as a standby, waiting to take over if the primary fails. It is tempting to look at the active-active setup and assume it consumes twice the energy because it uses 2 regions. But total energy consumption scales based on the number of user requests being served, not just the physical hardware you provision. Both regions do productive work that would otherwise be piled onto a single massive central server. Active-passive, however, carries a distinct energy penalty. For the secondary region to guarantee a fast takeover, its database has to stay continuously synchronized. Those standby servers are plugged in, running, and drawing continuous power. You are paying a permanent carbon cost for hardware that produces 0 productive output. If you want to dramatically improve user response times while simultaneously reducing your application's carbon footprint, you introduce a Content Delivery Network, or CDN. This diagram illustrates a CDN. Instead of users crossing an ocean to the origin, cached copies sit in smaller hubs close to them. A well-configured CDN achieves a 98% cache hit rate. Your origin server only handles 2% of the traffic. This works incredibly well for static content that stays the same for everyone, like images, video files, and fonts. It does not work for personalized dynamic data, like a livestock price or the contents of a private shopping cart. But by keeping those static assets at the edge, CDNs drastically shrink the power required by your central servers, and they eliminate the massive energy costs of pushing heavy data back and forth through long-haul fiber cables. Let's look at how this plays out in practice with case study 1 from your text. A software platform is upgrading its single-region architecture to support 80,000 global users. Their European traffic is growing, so they need a second region. They have to decide between building a complex active-active setup or deploying a simpler active-passive model using a read replica. They ultimately chose option B, the read replica. Project management apps are read-heavy. Users load task boards far more often than they edit them. Adding a local replica cut their read latency from 110 milliseconds down to just 45 milliseconds. They rejected the fully distributed active-active approach. The engineering overhead of keeping database writes perfectly synchronized across continents was too risky for their small team, and it would have increased their operating costs by roughly 75%. And because they follow the decision hierarchy, they used carbon intensity as their final filter. They placed that new European replica in Sweden to take advantage of the country's highly renewable power grid. Sustainable IT architecture is rarely about designing a theoretically flawless global system. It is about making the smartest possible compromises between speed, budget, and carbon. Let's look at how you will be tested on these trade-offs in Quiz 9 and 10. Take question 1, which asks for the absolute first consideration when evaluating a new region. The correct answer is data residency rules. This goes straight back to the decision funnel. The exam will try to distract you with latency improvements or clean power grids, but none of that matters if your application is legally barred from operating in that jurisdiction to begin with. In question 3, on active-passive deployments, the common trap is assuming the secondary region sits completely powered down. As we covered, operational readiness dictates that standby servers must remain powered and synchronized so they can immediately take over during a failure. Question 7 tests your understanding of edge caching. It asks why placing your origin server far away in a clean energy region doesn't ruin the user experience. The answer is that the CDN is serving the vast majority of user requests directly from the local edge cache, bypassing the origin distance entirely. When navigating these test questions, be highly suspicious of any multiple-choice answer containing words like always or regardless. Multi-region design is entirely contextual. Passing this exam and designing real-world architecture requires evaluating nuanced trade-offs, not chasing single-variable absolutes. In Part 2, we will look at the specific mechanics of data replication. I'll see you there.